All right, let's dive in. We're going to talk about how to get way more out of your AI than what you get right out of the box. Because if you want truly next-level performance, the secret isn't always a bigger model, it's a smarter one. And today, we're unlocking that smarts through the world of fine-tuning.
So let me just ask you this straight up. Is your AI model really giving you everything it's got? Because if you're using a standard pre-trained model just as it is, there's a really good chance you're leaving a ton of performance and accuracy on the table. You know, it really all boils down to this difference right here. On one side, you've got your frozen model. Think of it like a tool with its factory settings. It's pretty good for a lot of general stuff, but it's not an expert at anything specific. But on the other side, you've got the fine-tuned model. This is like a custom-made instrument, shaped and sharpened specifically for the unique rhythm and notes of your own data.
Okay, so where do we even begin? Well, we start with the big one, the most thorough method out there, full fine-tuning. This is the path you take when you're chasing absolute peak performance.
So what is full fine-tuning, really? Well, imagine you take a super powerful pre-trained model, and instead of keeping it locked down, you unfreeze all its layers. Then you train it together with a brand new classification part on your specific job. They learn together, jointly. The original model isn't just giving advice, it's actually changing and adapting its own internal wiring, while the new part learns right alongside it. It's a true team effort.
And you can really see the difference it makes. Just look at this. When classifying Rotten Tomatoes reviews, a standard frozen model gets a pretty decent F1 score of 0.80. But by fully fine-tuning that same exact model on the same data, that score jumps up to 0.85. That's a serious boost in performance, all unlocked just by letting the whole model get in on the learning process. But of course, that kind of power doesn't come for free, and that leads us to the classic trade-off, speed versus power. So what if you need results and you need them fast? Well, that brings us to a more practical option, freezing layers. Because this is the real world we're talking about, right? Full fine-tuning is amazing, but it can take a lot of time and a whole lot of computing power. So what do you do when you're working against a deadline or you don't have a supercomputer in your back pocket?
To figure that out, let's just check out a little experiment. We're going to compare 3 different ways of doing things. First, we'll train everything, the whole shebang. Second, we'll train just some of it, a few of the top layers. And third, we'll train almost nothing at all, just that final classification piece.
And the results? Well, they point to a very clear sweet spot. While training everything gets us that top score of 0.85, look what happens when we freeze the whole model. Performance just falls off a cliff. But the magic is right there in the middle. By unfreezing just a few of the top layers, we hit a score of 0.80. You get almost all of the performance back for just a fraction of the time and cost.
Okay, so that handles the not enough power problem. But what if your issue is not having enough data? This is where our next technique comes in, and it is a total game changer. It's called SetFit, and it's all about getting huge results from just a tiny bit of data. Just look at this number for a second. 32. That's it. What on earth could that mean? Get this. It means that with the SetFit framework, you only need 32 labeled examples to get the same fantastic performance as a model that was trained on over 8,500 examples. I mean, that's not just efficient, that's almost unbelievable.
The visual here just says it all. On the left, you've got our fully fine-tuned model, trained on that whole big dataset, hitting that 0.85 F1 score. And on the right, the SetFit model, trained with just those 32 examples, hitting the exact same score. This completely levels the playing field for anyone who doesn't have a giant labeled dataset to work with.
So how does it pull off this magic trick? It's actually a pretty clever 3-step process. First, it takes your tiny handful of labels and intelligently creates thousands of positive and negative sentence pairs. Then it uses a smart technique called contrastive learning, which basically teaches the model to pull similar sentences together and push different ones apart to tune itself on all those pairs. And finally, it trains a simple classifier right on top of these new, supercharged embeddings.
So far, we've been getting models to learn specific tasks. But what if you need the model to learn a whole new language? Not like Spanish or French, but the unique language of your industry. This is where we give the model an expert upgrade with continued pre-training.
The thing is, a model trained on something really general like Wikipedia is a jack of all trades but a master of none. It just doesn't get the specific jargon, the slang, or the hidden context of specialized fields, whether we're talking about medicine, finance, or in this case, movie reviews.
The solution is this really powerful three-stage pipeline. So you start with your general model, then you add this crucial middle step. You continue pre-training it, but this time you're only feeding it text from your specific domain. This actually adapts the model's core knowledge base, and only after it's learned the lingo do you fine-tune it for your final task, like classifying sentiment.
Let's see what this actually looks like. Before we do this domain tuning, if we ask our generic model to fill in the blank for "what a horrible mask," it spits out these very generic words: idea, dream, thing. I mean, they fit, but they're not specific at all.
But after we've pre-trained it on a ton of movie reviews, the model's predictions completely transform. Now it suggests words like movie, film, and comedy. It has learned the context. It's not just speaking English anymore, it's speaking the language of cinema.
All right, up to now, we've been classifying whole chunks of text, getting the big picture. But what if we need to zoom all the way in? Let's talk about getting super precise with word-level classification using something called named entity recognition, or NER for short.
So, NER is a type of fine-tuning where the model learns to go through a sentence and classify every single piece of it, every single token. Its whole job is to find and label specific things. We call them entities, like the names of people, organizations, or places.
And here's a perfect example of how that works. In the sentence, Dean Palmer hit his 30th homer, the model is smart enough to see more than just two words. It tags Dean as BPER, which stands for the beginning of a person's name, and it tags Palmer as IPER, for being inside that same person's name. That's how it knows that Dean Palmer is one single unit, a person's full name.
And why is this such a big deal? Well, the real-world uses are incredibly important. NER is the tech that makes it possible to automatically hide sensitive information in documents, to pull out key facts like company names from long reports, and to power those really smart search engines that understand who you're looking for, not just the words you typed.
So from full fine-tuning for maximum power, to freezing layers for speed and efficiency, to using SetFit when you barely have any data, and all the way down to Nerve for pinpoint precision, you now have this entire toolkit to go way beyond the basics. So the only real question left is this. Now that you have the keys, what amazing potential are you going to unlock in your AI models?